So as you can see here, Arduino is an open source electronics platform based on easy to use hardware and software. So if you will visit the website www.arduino.cc, then you will be able to see that the main website or web page where you can see the original Arduino store, and this is the company that created the Arduino. And you will see here more information about Arduino. And as you can see, the use of Arduino, we can read inputs. For example, you have a sensor or you have a switch, you can use it to activate any electronic component like LED or a motor. But of course, there are more things about Arduino here that you can find out by simply looking at this link. Now, just to continue with my slides, we will be able to use Arduino because even though we don't have a good background in programming, it will be easier for us to create some project. Now, the microcontroller used by Arduino Uno or Arduino, for example, here is 80 mega 328P microcontroller. And as you can see, it has a microcontroller that controls inputs and output. And one specific board that I will be discussing right now is the Arduino Uno. This is the Arduino Uno. Now, it is user-friendly. Why is it user-friendly? As you can see in the beginning, we are discussing the main features of Arduino. First, it has a microcontroller. Second, it is user-friendly because it uses similar language to C or C++, and the integrated development environment is, as you can see, this is a simple program that will turn on and off the LED. So you will see here that it's not as difficult as other languages. And this is the integrated development environment of Arduino where you can create some program. Now, number three, it's extensible. You can extend the Arduino Uno so that it can do other things. And we can do that by using ultrasonic sensor or other sensors available for Arduino. And we can also attach or put something over the Arduino board. And we call it a shield, like this shield, which is used to connect to the internet. Now, these are some examples of the uh, devices or sensors that we can connect to Arduino. For example, you want to create a sound, then you can use this passive buzzer uh, electronic component so that there will be a sound to your project. Let's say you want to measure the temperature, then you can use the DHT11 module. You can also measure the humidity using this additional component. If you want to use a relay, there's a relay here. If you want to detect the light, if there's light or there's no light sensor, we can use the photo resistor. If you want a joystick, we have the joystick module. If you want to detect gas, if you have a project that will detect the presence of gas for safety purposes, then you can use the MQ2 module. We can also, for example, clap our hands to turn on or off the lights. Then we will have to use the sensor or the sound sensor module. So these are some examples of the other electronic components or sensors or devices that we can connect to our Arduino project. Now, these are the shields that are available for connecting to the for connection of Arduino Uno. So over the Arduino Uno, you can attach. This is the one I showed you for connecting to the internet through the Ethernet. And you can also use GPS your project, or you can use the LCD shield, and other shields are available for your Arduino to be attached over your Arduino. So when you say attached, that means this is the board that you will put over Arduino. Next, number four, it's community driven. If you are beginner to creating projects in Arduino, there's a lot of community and groups that are also doing projects same as you, and you can learn a lot from them. So it has a lot of online community for support and resources. And Arduino forum lets you ask some questions, share ideas, and if you have a project, you can share it with them, and the others also will share projects to you. Now, the Arduino hardware, the main part is the Arduino board, and there are different boards that you can use in Arduino. The three major or main boards being used all over the world is first, of course, like today, because we are just beginners, we will use the Arduino Uno. And the other one, if this is not enough and you need more pins or more things to do, then you can use the Arduino Mega. And then we can also use the Arduino Nano if what you're doing is just a very small device, or it does not need huge tasks. Then you just need a small space. You can use Arduino Nano. Now, if you look at Arduino Uno in the website of arduino.cc, here we go here. Okay, this is the original board, and of course, you will see that it costs $27 here, but there are cheaper boards available online. Okay, but we are talking about the Arduino Uno. So this is the Arduino Uno. This is the back side, and if you buy the original one, this is the box that you will receive together with plastic under. And the Arduino Uno is a microcontroller board. Okay, and it's using 80 mega 328p. You can click the datasheet here to see some more information. And there are 14 digital input output pins, and we will be able to use 6 analog. So this is the link for that one. Now let's go back. In the case of Arduino Mega, of course, the Arduino Mega, it's called Mega because it's huge. And this is, for example, you have some robotics projects and you want to use more pins, then you can use the Arduino Mega. As you can see here, it's using 80 mega, it's using 54 digital input output pins, more than the input output pins of. And with regards to the analog, it's using 16 analog inputs. Now, for Arduino Nano, this is the smaller version of Arduino board that you can use for small projects. This is the one. And it's much smaller compared with the other two Arduino boards that we are using. And it's cheaper. Okay. And of course, there are other boards available, not only that for Arduino. But we will focus on the basic one. Now, the microcontroller is the brain of the Arduino, and this is responsible for executing the program. And the input output pins, we have digital input output pins, and this is from the number 0 to number 13. And this digital input output pins has also have some other function, not only for digital purposes, but for serial communication and for PWM output. Now, for analog input output pins, we have A0 to A5. This is for analog values. Now, special pins under the digital I/O pins are RX and TX used for serial communication. We also have AREF, analog reference, for the voltage pin, and the reset used to reset the microcontroller. Now, for power supply, we can connect the USB Type B to our Arduino to power it up, or you can use the barrel type plug that is connected to a 9 volts battery. And you can also use the external battery source connected to the voltage and grounds part of our Arduino board. Now, the USB here is fixed to 5 volts, but the barrel jack can accept from 7 to 12 volts. And on this part, we can put 5 volts or 6 volts up to 12 volts. Now, the Arduino software that we need is called Arduino IDE. This is where we will write our program. And the program that we write, we call it as Sketch. Now, for the other one, the example of the program that you can see here, this is related to C language. So for those who have background in C language, that's a plus because you will be easily understanding the Arduino program if you have a background in C language. But even though you don't have a solid background in C language, it's still easy to use compared with other boards available in the market. Now, the libraries contains the other functions that is necessary to be able to do some work for your projects, which is difficult to do if we will be the one to program it. So we can just include some libraries and import them so that we can do some tasks which are done regularly or it will be repeatedly done. Now, also, there's what we call a serial monitor. This is a tool for seeing the debugging and monitoring communication between Arduino and your computer. To get started, of course, you have to download and install the Arduino IDE from the official website. And if you go there, you will be seeing some ways to download the necessary IDE or the software that we need so that we can write the program. So whether you're using Windows or Linux or you're using Apple computer, you can download one of these. Of course, for those who are using Windows, you can simply download the zip file here. And when you click it, then it will be asking you to either donate or just click just download. And from there, you write your email and the necessary information, and you can download the software which is required for us to be able to create our program. So this is the link. I'll provide you with the link at www.arduino. Now, to connect the Arduino, you need a USB to connect here and then connected to your laptop on the other end using your USB cable. And of course, after you open the Arduino IDE, you have to make sure that you have selected the proper board because there are so many boards available. So you have to click Tools and then the board, Arduino Uno, and then you choose the board that you need, which is Arduino Uno here. Or if you want Mega or Arduino Mini or Arduino Micro or Arduino Nano, whatever board you have. But for this particular webinar, I will be using the Arduino Uno. Also, when you connected your Arduino Uno, make sure that you have selected the proper serial port that you use for your Arduino. You have to click one of them. Like here, you have COM9, COM10, COM4, or COM7. Usually, when you connect the Arduino Uno to your USB, it will be showing the name Arduino Uno on the right side of your screen. And then you have to click it to make sure that your program will really be working later when you run the program. Writing our first sketch, which is to create a simple program which will be to blink a light using the light emitting diode. So this is the program that we will be doing, and I prepared the program here already. So as you can see in line number one and line number two, I just made I just made a I just made an example here where you will see here that number one and two are just comments, and then number three is setup. The setup function and the loop function is necessary. Excuse me. Number five, this is where you tell which pin you will use from 0 to 13. So because I want to use number 13, so I put 13. And then the loop here, this number 10 is to turn on the LED or the light. Number 11 is 1 second delay. Number 12 to turn off the LED, and number 13 is to have a delay. So 10 to turn on, 12 to turn off, and then 11 is the delay of 1 second. So this is the basic program that we can. Another sample program here is we have a potentiometer or a variable resistor that we can use to control the light of our LED. So if you want to see how it works, for example, here, if I, as you can see, the light here of this is a simulator. walkway simulator that you can use. If you drag this potentiometer, you will see it's not really dimming, but it's controlling the number of delays, okay, or the time that the light will blink. So as you can see in this program, I declare a variable equal to 0, and then the variable s will depend on the value of the potentiometer here. So if you rotate the potentiometer here on the leftmost side, then the blinking will be very long before it blinks. And if you move it slowly, you will see that the blinking here, it's very fast. I mean, that we cannot see the blinking anymore. So if you turn it clockwise, you see that the blinking is getting slow. And if you move it more on the right, it will be very slow to blink. Maybe now it's between 2 seconds, or and then if we put the maximum time, then it's blinking every maybe 2.5 seconds, or something like. But as you can see, I can control the blinking of the light here using this simple program, right? So I put here some explanation about the code in case you are just a beginner. What is this? Of course, if you have a background in programming, that's the language. Like number 12, you declare letter S as a variable, and then again, number 16, you just tell what will you do with your pin. If it is 13, what will you do? Will it be input or output? Because it's a light, so we put output. And then on number 20, we read the value of our A0 here, which is connected to your analog 0 pin connected to your potential. So if I want to make a program like this, I can look at some examples, and then I will just run it. After running, then I will edit whatever thing I want it to. Next, we have here some examples. Let's see some examples. All right. So in this example, as you can see, first thing you have to put the LED. You can click plus. You can open this walkway.com so that you can try it. You click plus. You click. You select resistor, and then you move the resistor near the LED, and you can rotate the LED, and then you can put the LED on the left side of the LED. We call it as the cathode side, and we connect the ground GND of your Arduino Uno to the resistor, and then the resistor connected to the LED. Okay, and then the anode side, the right side of the LED, will be connected to number 13. You can also change the color of the wire. You can make it black, for example, here, and then you can drag it to number 13. And then after that, you may uh, now change the color of the wire. You can use red color for your wire. And then you can now write the program. So on the left side, you will see that I'm writing now the program. Again, we have to declare the number 13 as output. So we put pin mode 13 output. If you use other pins, then you have to declare them also. And then inside the loop, you will just tell what the program will do. So for example, I want to turn on the LED, so I'll just write digital write 13, comma, high, or you can also put 1. So digital write 13 1 will turn on the LED. After that, we will make a 1 second delay. And we need to make the letters small, so delay 1000. This is 1 second delay. So the light will turn on for 1 second. And after 1 second of turning on, copy paste the program. Instead of on, we make it off. So how will we make it off? We will just make it digital write 13 0, and then delay 1000. Do you have any question? Is it clear? That's how easy to do this example. And then we can run the simulation now. And when you run the simulation, the LED is now blinking. So after our webinar, you can try this from home. Just register to walkway.com and you can start making a project like this. Okay. Now let's go ahead, and then here when you visit this link, I already put some explanation about what the program is doing. So as you can see, we declare the function, declare the digital pin 13 as output, we turn on the LED, and then we make a 1 second delay, and then we also declare the uh, or we turn off the LED, and after that we have a delay of 1 second again. So that's what you will see here in this example. Now the comments are started with slash slash if it is a line comment, but it's not really necessary. So the curly brace also, you may put it after the function, like number 4 and number 9. So you may see also some more examples in my YouTube channel, ERC Tipsnology. At the end of the webinar, I will give you the link so that you, okay? So this is one example. Now, if we go ahead and continue, I have lots of example here. Let's try to blink the LED, this time with the real board that we will be using the real board. So if you visit the link that I will give you later on, I have made or created a YouTube video for this, and here you will see the Arduino Uno, the real actual Arduino Uno. And as you can see here, from letter number 0, 1, 2, 3, 4, 5, 6, 7, up to number 13, these are the digital pins 0 to 13. Okay, so you can use 13 input and outputs there. Analog pins A0 to A5, we can put 5 analog connections. And this is the ground, G and D. As you can see, there are two grounds here. And this is the 5 volts and 3.3 volts. Of course, the board has other parts, but these are the main basic for beginners. And then this part is where we will put the USB input, or you can also use the DC jack. And if you want to reset the program, you can click the reset button. And there's also a built-in LED connected to your digital 13 with letter L. And when you upload or download something to your board, you will see the TX and RX light. Now, for the breadboard, this is also called solderless board or proto board. We need this to connect our circuit. These are the positive points, and these are the negative points, and they are all connected together. Now, the A, B, C, D, E vertical, these are called the terminal strips, and it's like series connection, okay? A, B, C, D, E, vertically, you can connect 5 holes together. And we have from 1 to 63 on this board with A, B, C, D, E connectors. On the top part, you will also see F, G, H, I, J, which you can also use to connect your circuit. These are another terminal strips set at the upper part of your breadboard, up to 63 also. And we also have positive power rails at the top, and also the negative power rails at the top. So this is what we call as breadboard. Now, this is the LED or the light emitting diode. And in the LED or light emitting diode, as you can see here, we have the anode and the cathode of the LED. The shorter one is the cathode. Now, the shorter one is the cathode. Yeah. Now, if we go back a little, we have the resistor, and the resistor that I used here in this example is actually 1 kilo ohm. Okay, we need also to have to measure it. So this is a 0.986 kilo ohm. Actually, it's approximately 1 kilo ohm. And we need connecting wires to connect our circuit. And we will be using red and black connecting circuit, connecting wire. Now, what we will do now is we will connect the uh, cathode, the shorter leg of the LED, to our breadboard. We can choose any point, but for this example, you will see later on where I will connect it. But then the longer leg of the LED, that's called anode. Okay, so for those who are doing 105 now, I think you are done with diodes, so you know this. Now we connect the cathode to one of the negative power rails, and then the anode we connect on one of the points here. I connected the cathode to the negative power rails, and I connected the anode to letter A5. I hope it's clear. Is it clear? I put it on A5, all right? Do you understand the circuit? Then we connect the ground, G and D, and we will connect it the ground connected to your negative or to the cathode of your LED. So the negative horizontally are connected together. So we connect the G and D of our Arduino, the negative of the power rail, as you can see here. I will upload this video later on, or there's a link I will provide to you so that you can go back on this example again. And now the other end of the LED is connected on A5. We need to put a resistor in series with our LED. So the 1 kilo ohm resistor will be connected to either B, C, D, E, but I chose letter E. That will be in series with letter A. So E5, I connected A5 to E5. And then the E5, I connect to number 10, vertically number 10, but on letter E. So I connected the resistor, the other end on E10. Therefore, whatever I connect to A, B, C, D, 10 will also be connected to the resistor. I hope it's clear. So now the A10, which I chose for the positive, will now be connected to pin number 13 of our Arduino. And that's it. We have connected the negative cathode to the cathode and the anode to the resistor and the resistor to our digital pin number 13 in series without using soldering iron. This is used for what we call as prototyping so that it's more easy for us to do the project. Now we connect the power or the USB connector type B to our Arduino Uno. And then after that, the other end, we will be connecting it to our laptop or to the USB of our laptop. After that, we open the Arduino IDE where we will write the program as I have told you. And let's start writing the program. Of course, we write the comment maybe for information purposes. And I think I wrote this last week, February 27. And then on number 5, we need to determine what will we do with number 13. We will use it as output. And then we will turn on the LED. And we will put the 1 second delay. After that, we will turn off the LED and we will put another 1 second delay. Is it clear? Do you understand how I explain it? Again, this is for beginners. Huh? And then make sure that your board is correct. Okay? So how? I think it's a little fast now. But look, I chose tools and then you choose Arduino Uno and the COM port that you will be using for your Arduino. And make sure that you chose Arduino Uno. Okay? And then the COM port that you will be using, you have to select from the communication ports wherever you connect your Arduino Uno. So here, if you connect the Arduino Uno, you have to check after connecting. You click Tools again, and you will be able to see the COM number 5. You see the COM 5? It now has the word Arduino Uno. It's very important to make sure that there will be a check mark on this Arduino Uno communication port. So you have to click that one, click it until you have a check mark. If not, then your program will not work, will not be downloaded. See, it's not a check mark, it's a bullet. You see the bullet there, the black circle, the small black circle near the, no, not that one. I mean the check mark near the COM5. See that one? There's a, yes, that one. Check mark on COM5 Arduino Uno. If there's no check mark there, then your program will not run, because it will not be downloaded to your uploaded to your Arduino board. Now, after writing the program, what you do now is you have to click the check mark at the top of the screen. Okay, so that we will check if there's an error in the program, so that you can compile. So after you click the check mark at the top to verify if there's any error, if there's no error, then you can click the upload button. Okay, so click the upload button, and what will happen? It will go to your Arduino Uno. As you can see here on the right side, I uploaded the program to my to my Arduino Uno board, and it will also run. So look what's happening. See, the light is now turning on and off every 1 second. And this is your first project. It's like the Hello World project in Arduino. Is it clear? Do you have any question? Fine. Okay, so now the LED is now blinking every 1 second. That Now, if you change the delay, let's say you change the delay to 500, what do you think will happen? It will become 500 milliseconds, or it's zero point 0.5 seconds. So the light will blink faster. See that? It's now blinking faster after you click the verify and the upload button. Now, let's try to change it again. This time, let's make it 250. What do you think will happen if I make it 250? Of course, the blinking will be much, much faster. Okay, let's compile and upload it. Look at this. So on the right side, you see the LED is blinking much, much faster. Okay, so I hope it's clear, and let's put it back to 1000. So in other words, you can change let's make it 50, for example. If it is 50, look, see, it is 50. See that? Blinking so fast if it's 50. Now make sure that whenever you use the LED, there's a resistor in series with the LED. Now if we make it 2000, what will happen? Of course, it will blink much, much slower, okay, than that one. So it will count 2 seconds before it turns on and off. All right. So you can go back to this example later on by visiting the YouTube channel that I have created, and let's go ahead with some other examples here. For Anyway, let's see the other one. Other link. So this one, let's use a switch. Now, again, let's just do the simulation using Walkwe. You put the connection like this one, and if you visit this page or video, you will be able to see how to write it. But I don't have time to write all one by one, so I already put the program here, and I just put the explanation on the right. So this time I'm using not just one but four pins, and as you can see here, I'm using three pins, number 0, 1, and 2 for the output, and then number 4 for my switch. So in this example, we will have four pins for our Arduino Uno, three output and one input. So that's number 0, 1, 2 for the output, for the green, for the yellow, and for the red LED, and number 4 for the switch. Now, on the other hand, main program, the loop, we declare a variable s to read the switch. So we will read the switch whether the switch is on or off. And then we have a delay of 10 microseconds just to make sure that the switch will work. And if we turn on the switch, or the switch becomes 1, then what will happen is the green will be on, yellow will be off, red LED will be off, and there will be a delay of 6 seconds for the traffic light, right? The green. And then after that, after green, the yellow will turn on for 3 seconds. After that, the red will turn on, this time for 6 seconds again. Now, if you turn off the switch, what we will do is we will just turn on and off the yellow LED. So as you can see here, if the switch is low or off, the yellow LED will turn on for half second, and then it will turn on and off for half second. So let's try to run the program. You can try this after the webinar. Just create an account in walkway.com and then copy the program that I gave you. And you can visit the YouTube link or the other references that I'm giving you at the end of webinar. And this is good for you in practicing your electronics instrumentation or power. Okay. Now, anyway, this is the output. As you can see, the traffic light is turning on here, and then the yellow, and then after that we have the red. So that's the example for this. Now for other examples, I have more here. Let's say you want to display a message on the LCD. Let's try to display a message on the LCD. So this is the LCD, and you can watch another reference how to connect this correctly. And we will display, for example, something on the liquid crystal display LCD. Just connect your LCD on the Arduino board and follow the video on how to connect it correctly, because there are lots of wires that you have to connect correctly before the LCD will work. As you can see here, I'm connecting the ground, the RW, and the BLK, and then I will be using also resistors connected to our LCD. And I cannot slowly show you how to do it, but you can go back to this video so that you will see how to connect them. But it's not only one, two, or three pins that we are using right now. I don't know if it is still for beginners, but I think this is still for beginners. It seems like there's a lot of wire connected in this project. And then we need to use a variable resistor here. Everything is given in this video. I mean, you can try it after the webinar and make it work yourself. If you don't have the kit or the Arduino, then you can also do it online using the links that I will give you so that you can practice your doing this project. Now, let's say you have done connecting following this guide, all right? How about the program? Let's forward this. This is the program. Okay, this is how the program is. You will see here number 53, LCD begins 16.2. This refers to the number of rows that you can use for your LCD and the number of columns. And then we will just display hello world. Okay, that's what we will do. And we will put it on line column number 0, or row, the first row, and the first row, column 1. So let's see how it will come. See, this is the output. See, it will display hello world, and at the same time, it will also display the second from the time that you started running the program. So let's try it. Okay. Again, you can copy this example. So look, hello world, 1, 2, 3. It's now displaying the message counter. That. So this is another example that you can try. And the code are there. The program is here. You can copy. And there are also examples in the Arduino IDE. So if you follow this video, you will be able to run this program, hopefully. Okay, now let's see some other examples. For example, you want there's an intruder or someone trying to steal from your home. You can create a sensor that will detect them by using ultrasonic sensor. Now you can also try tinkercad.com to create your project or to simulate it. Just create an account in Tinkercad, and then you can easily choose the Arduino Uno, and then with the ultrasonic, and the programs are also available there when you put it, and then you will just modify them a little. So in this example, as you can see, I use the same LED and resistor there, but this time I use a buzzer. And then I connected the buzzer on pin 12, and also the program here is shown in this video, and how to connect the ultrasonic sensor. What will happen here is that when you run the program and there's someone trying to go to your house or home, and it is detected by your ultrasonic sensor within that range, then it will have a buzzer sound on your project. So the buzzer will turn on and off, and it will be blinking also the LED. So if we try to run this program, let's forward it that it will be running. Also, you will see here the serial monitor, the one where you can display what's happening in our sensor here. Serial, it will display the inches, how far is your intruder from the ultrasonic sensor through the serial monitor. But of course, in the beginning, you have to copy some examples so that you will see the output, and then you will try to understand the program. I mean, if you are asked by your teacher to create a simple project, and should be having something like a specific goal of helping someone like this one, it helps you detect some intruders. Then you can use this online simulator to try it. So as you can see here, it's done, and now we are simulating the program. See, when the intruder comes close to our range, then the LED will be detecting the distance. And so with a particular distance, we can, let's make this forward. You see, it's 122 inches. And when you go near, the buzzer will sound. Also, the LED is blinking. And it blinks faster and sounds faster when the sensor detects it's close. Can I make this project if I'm a beginner? Yes, of course. All you have to do is to copy from the examples given. Okay. Now, what other examples I can show you? There's a lot here. Okay? You can make a temperature and humidity sensor project. Then you can display that on screen. You can also detect using RFID. If you click this link, you will see how it works. RFID, or radio frequency identification. So like the one we use in the college for detecting the parking area to turn open or close, or even the door. You can even use make a robot, a talking robot, where you can tell it what to do. Will it turn on or off the light? If you visit that link, you will see how it works here. This example. So the robot will talk. If you say turn on the light, will turn on the light, turn on the AC, turn on the radio, turn on the TV. It depends. And the appliances are just represented by LED. You can this one, another student, he made this robot, but he is controlling the fan, or the electric fan, not only the light. It also talks. It can answer to your to your words, or to the things that you are saying. So it's voice activated. This is another example. It has a car. You can control the car by remote control, by mobile application, or by voice. And these are the parts of that project. And in conclusion, Arduino can provide a beginner-friendly platform for learning electronics and programming, which is very useful in rapid prototyping or creating interactive projects even with a limited time. So we don't need to have a good knowledge, very good knowledge in programming, although it helps. And also we need a working knowledge of electronics. So right after this seminar, I hope everyone who attended may start making your Arduino project. Now, these are the references, and you can visit my YouTube video here at ERC 2020.